Welcome back. This instruction is for students taking the Cisco NetPat CCNA 2 course, and we are configuring the final exam. Today's configuration is going to be NAT and PAT on the Wadsworth router you can see here. Our 155.1110/26 is your address in between your serial links. I believe we did 155.111 on Copley and 155.112 on Wadsworth. So we're looking to take the internal IP of 10.10.10.0 network and translate it to the 155.110 network. With your 26-bit mask, that would make your subnet mask 255.255.255.192 with an increment of 64. So your network address is 0 through 63. And we're going to publicly map this web server to an IP, and I believe that's going to be 155.113. So let's go ahead and look at our config over here. So we're looking at the Wadsworth router, and you can see the IP subnet mask. Here is our internal 254 IP. So let's go ahead and make sure the server has an IP of 10.10.10.254 and gateway. So just make sure that works properly. We will ping the gateway, and that's successful. So I was able to ping the gateway of 10.10.10.1. So first thing we're going to do is do our NAT inside and outside statements. So I'm already in config T, so interface gigabit 0/0. And this is going to be defined as the IP NAT inside address. A common mistake for students is to reverse them and make the gigabit the outside and the serial the inside, or vice versa. Go to interface int s0/1/0. I'm going to arrow up to save typing. Hit tab outside. Then you can see the config here. This is where most students have a hard time. So this first statement is defining a NAT pool named Wadsworth. We're going to use that again in the NAT source list down here. So 155.1110 to 1120. So that's what we're going to give out on the public side. So 10 through 20. If we use more than 10 addresses, then we're going to use the overload, which we use the IP on the serial interface for all connections that need more than 10. So the 11th user would use the overload. And then the third statement is mapping the internal IP to the global outside. So anybody from the internet will reach the server now by doing that IP address or the domain name. And then we have to write an access list statement to allow the 10 network to be translated. Another common mistake is students will put the 155 network here, and that's a mistake. Just go ahead and try to configure and test. There is a typo. And you can see that I don't have enough in my second address here. So one simple typo, and you can see the caret said right here that there was a mistake, is because I forgot the dot. So IP NAT inside source list. Now this is where the ACL comes in, and the name is ACL. So that ACL matches there. This name for the pool name matches up here. So make sure you have no typos when you're typing that. Then we're going to map our inside internal address to the outside to the real IP that people can reach it from the internet. And then write your access lists. So we're permitting any IP with 10.10.0 and the inverse mask means the first octet match, the second octet match, the third octet match, and then a fourth octet ignore. So anytime there's a 0, there's an exact match, and then anytime you see 255, it means ignore. It doesn't matter. So 1 through 254 is what we're saying here. Any IP between 0 and 255. All right, so that's it. So let's go ahead and test. And a quick way to test is go to a computer, put in the IP 155.1.1.3, and you see a web page. Okay, so we're using HTTP, so we should be able to see the translation in the router. Control Z, exits me out, show IP NAT translations. And you can see here my public outside going through port 80 to the internal IP going to port 80. So the next thing I'm going to do is test pinging, because in the next video you're going to see that my ACL, once I play an ACL, pinging will stop. So ping 155.1.1.3. And once again, and so to generate a little more traffic, I'm going to use the extended ping -n space 15. Now instead of pinging only 4 times, it'll ping 15. Therefore generating more translations here. So at this point, our NAT and PAT translations are working. So this concludes the video.